Kia ora, welcome to our PLD session looking at Dinosaur Steps. We are ByteEd. Welcome, haere mai, tēnā koutou, tēnā koutou, tēnā koutou katoa. Ko Sarah Washbrook toka ingoa. My name is Sarah Washbrook and I'm going to be helping you today to support you with your understanding of using Play Code Learn Dinosaur Steps in the classroom. I'm Product Development Lead at ByteEd and I've helped to develop and design the teaching resources that we're talking about today. ByteEd are a educational company who design and create lots of different technology resources to support learning in the classroom. We're made up of digital experts, so computer programmers who specialize in modeling and AR and VR, and educationalists. Today's workshop, we will be exploring digital technologies and computer science. So we're going to be having a look particularly at computational thinking and how to teach computational thinking with Play Code Learn. When you see the icon on the right-hand side, which is the pause play, that indicates you need to pause the video and do an activity. If you would like to access these slides, you can see there is a QR code and a bit.ly for you to be able to access the slides at a later date. So we will start with a background of approaches to teaching digital technologies. Across the world, there have been lots of changes in computer science. And the key thing that people need to understand now, especially as teachers who are using lots of digital tools in the classroom, is the difference between e-learning or ICT against what's called digital technologies, particularly in the Southern Hemisphere, or computer science. E-learning is essentially the use of ICT tools. It could be software and it can be hardware. Many teachers will use lots of different tools in their classroom to aid and support learning. Digital technologies, however, is more than just using the tools. It is about getting the students to be creators and problem solvers and using these tools in different ways, and indeed sometimes even designing and creating their own digital tools. As teachers, you need to be aware of the difference between e-learning and digital technologies. At ByteEd, we follow different pedagogical approaches. One of the main approaches that we use is called the SAMR model. And the SAMR model helps you as teachers to decide which tools are going to be effectively used in your classroom. When we're looking at starting out as teachers using digital tools in the classroom, predominantly we will start out by just substituting. So an example of this would be if you're getting your students to design and create a poster presentation, where they're actually showcasing information they've found out about a theme or a context. Now, the analog version of this would be a physical poster that they would put on the wall, and then people can go and read it and find out information. If we were going to substitute in the SAMR model, then it would be people probably nowadays using some kind of slideshow presentation. So Google Slides or PowerPoint or something else like that. Now, it is usually just a swap. It's still showing information. It may still be showing images, but basically you've just swapped from going the analog, hands-on, to being on the computer. Augmentation is when you've chosen the digital tool because it actually helps in some way. It may have some advantages to using that tool. So an example is actually this. This is a Google slide, but I'm able to record information, or I could put in video, or I could put in links, which we couldn't do if we were just doing the analog. Now, this is where teachers and students usually start in this substitution augmentation stage. What we want to do is move students up to modification and redefinition. This enables them to have much deeper learning and thinking skills develop more comprehensively. At this stage, they're not just using the tools, but they're redesigning the purpose of these tools, and they're creating new things and exciting things to help them. And at ByteEd, with our Play Code Learn series, we start off obviously introducing how to use tools, but as we work through the series, we enable the students to become creators. When Play Code Learn was developed, we came up with a huge series of things that we needed to identify that we wanted, linking to current practice in the classroom, educational pedagogical models. And when we brought all of this together and the knowledge and skills and techniques needed for computer science, putting all this together, we developed Play Code Learn. And that's what this slide here is identifying, is the thinking behind our Play Code Learn series. Today we're going to be focusing on the first kit in the series, which is Dinosaur Steps. All of our kits link to computing curricula from across the world. We're going to focus on decomposition, sequence, programming, algorithms, and debugging today. So first of all, we're going to think, what is computational thinking? Something I pose to my students is, can computers think? What do you think? So think about that for a minute. The next thing I would do is actually show them this video. So that video can prompt lots of discussion with your students. It really hooks and engages them in, and you'll probably find some really decent emotional responses from your students about computers and can they think. But what do they still think now? Can computers think? Well, in fact, actually, computational thinking is not like thinking like a computer, because computers do not and cannot think. They don't have a brain like us as humans. And thinking computationally is not just programming either. Computer programming tells a computer what to do and how to do it. All right. Computational thinking enables you, the human, to work out exactly what to tell the computer to do. So it's very important for us as humans to learn about how to think computationally, because then we can have success when we are programming or looking at how to tell instructions to robots and computers. In computational thinking, there are different concepts. Here are some of those key concepts, which we will be exploring further as we go through the PLD. Computational thinking, well, why is it important? Well, there's lots of research out there to support this. It helps the students to have those future-focused skills and employability skills that they're going to need when they go into their careers in their future, but also their schooling of the future too. And as we can see here, people think it's quite difficult to teach it, but actually the basics are actually quite easy to implement and start in the classroom. If we're looking at the jobs of tomorrow, the skills that are needed now by the students who are going into the workforce are actually these computational thinking skills, analytical thinking and innovation, active learning, problem solving, critical thinking, analysis, creativity, originality, and then technology use and technology design. So it's fundamental that we give these skills to our students. When starting off getting your students to think about computational thinking, there are lots and lots of unplugged activities to hook them into learning. Unplugged means that it is an activity that you do without the use of a digital device. Here is one example at the moment. The video, it says it's unavailable. It was a countdown timer. So you can set this up for your students. But one activity you could do is getting your students thinking about, how do they get to school on time? What do they need to do? And they could create and prepare a list of every single thing that they need to do, and even break that list down into sublists if you wanted to. So, for example, if they're getting dressed in the morning, what exactly does that need? And what does it do? So, what activities do they have to actually do to get dressed, or make their breakfast, or actually physically get from home to school? What are the activities they can do? And they can break down those tasks bit by bit into a very, very detailed sequence of instructions. By completing this activity, then you're starting to introduce some of these computational thinking concepts. They're starting to write instructions and put things step by step, which means they're actually starting to write what we call algorithms. These will be written algorithms. They may find errors and have to debug those errors. They may have used problem solving to think about things and to put things in the right place in their brains when they're thinking about it. And obviously, they're having to think about the logical order of the sequence in which they have to go through to complete the task successfully. They're also using something called decomposition, where we've said to them, what do you have to do to get to school? And they've taken that one task and broken it down into lots of mini parts, lots of small tasks. This will enable them to check for errors, check for anything that they've missed, but also make sure they're using logical thinking to get things in the correct sequential order too. Now we'll explore using computational thinking with Dinosaur Steps itself. For this, you will need the Dinosaur Steps kit. At ByteEd, we use digital technologies in different ways. Here are some of our dinosaurs from the Dinosaur Steps kit. All of them have been named after their characteristics, so if you wanted to explore that with your students, feel free. As you can see, we go through different design processes ourselves at ByteEd. So we go from two-dimensional images to popping them into 3D modeling software. Once we've created a 2D flat model, we basically blow it up so it looks like a 3D model framework. And you can see there that our Chompy the T-Rex has gone from a 2D illustration through to a colored 3D model that is animated and even has sound in the app too. When looking and using Dinosaur Steps, we use algorithmic thinking, and this is what we're going to start off with. What is an algorithm? Okay, well, an algorithm is a written, or it can actually be a visual form of step-by-step logical sequential instructions. Okay, so that is an algorithm. We can find algorithms all around us in everyday life. Many of us use algorithms in mathematics, so there's a great integration of other curriculum subjects that you can bring in here. But it can be very simple too. Written instructions could be something like a recipe. Yeah, it could be a physical activity, like the process that you go through to sort pencils into the correct length. You can use abbreviated literacy as well. So, for example, a knitting pattern or a crochet pattern uses abbreviated terminology, but when you follow it, you follow the sequence of putting something together. The routine that your students follow in the classroom. Yeah, what do they do when they first come into the classroom? Is there a process that they follow to get themselves settled at the beginning of the day? That could be an algorithm. They can also be visual. I'm sure many of you have seen Lego instructions, and they're a visual form of algorithm, step-by-step logical instructions for people to follow. So these essentially are algorithms. We're going to be using algorithms in our Dinosaur Steps kit. So you can have a look at the kit itself. You can open up your kit and you can have a look and see what different bits and pieces are in there. We have unplugged cards. We have a challenge booklet for your students to do unplugged challenges. We have instructional information. So there is always the instructional booklet, and there are visual instruction cards for those students who cannot read yet. And then we have the physical components themselves. So let's explore these a little bit more. The first thing that you would need to do is you need to put your jigsaw together. This enables students to work through and be introduced to several computational thinking concepts. And you can pause the video and read the examples that are on the right there so you can understand this a bit more. So you're going to use the kit to actually pop the jigsaw together. Okay, and then you will need to make sure you've got all the cards. So let's get ready to do that now. Remember, when this icon pops up, pause the video and get yourself ready and complete the activity. So first thing you're going to do is you're going to create an algorithm. You should have your Jurassic Park dinosaur land built. Okay, it should be in front of you. You will notice that it's turned into a grid. Yeah, so you've got squares in a grid-like formation on top of the jigsaw. You're going to write an algorithm. So the first thing you need to do is find the start and finish cards that are in the kit and choose 2 dinosaurs. Place them on the board. So you can see an example. You don't have to copy exactly mine, but you can put yours how you wish to. Okay, so place the start and finish and 2 dinosaurs randomly on the board, making sure the cards are inside one of the squares totally. The next thing that you will need to do is we have broken down the logical thinking for your students because many of them will be just starting out in this understanding of these skills and techniques. So we've really broken down the steps for you. The next step you do is once you have positioned your start and finish, you will see that in the kit there are these footprint cards. The footprint cards help to plot the path from start to finish, and you need to visit the dinosaurs on the way. So you can see my example, I have plotted a path. Now you'll also notice I didn't put a footprint on top of my dinosaur. You can do if it helps and supports learning. However, when I worked with students in the classroom, many of them said to me they didn't want to do that because they didn't want to stand on the dinosaur. And that's fine, as long as they don't forget that square when they're writing the algorithm. So now position the cards on your jigsaw and plot the path from start to finish, visiting the 2 dinosaurs on the way. The next step is to actually write the algorithm, and you will see that you have got arrow cards in your kit. To use the arrow cards, a forward arrow means that you're facing the bottom of the board and you're working up to the top, so up to where the volcanoes are. So you're moving forwards, upwards. If you turn the cards to one side, then you're going to actually move one whole square to the right or to the left. And notice it's move a square. In this kit, we do not rotate in place. Okay, so it's not like some robots that you can see out there. We've really started very simply for students who are just learning. So what you need to do is you can see I've written an algorithm. Now my algorithm is linear, vertical, and we can read the instructions from top to bottom, and it should, hopefully, follow the path that's plotted. Now, your students may also do vertical, but they could potentially write it reading from bottom to top, and that's fine. They also may be able to write the algorithm horizontally using the command cards, and they could read from either end, and that's fine too. The key thing is actually writing an algorithm using the command cards. How it's laid out is not important, as long as they know how to read the instructions correctly. In classrooms, I even see students actually draw the algorithm in the shape of the path, and that's fine too. In fact, some younger learners may put the cards on top of the footprints first to actually get the arrows and directions correct before moving those arrow cards off the board to create a separate algorithm. And that's a great way to break down the process too. So now write your algorithm using the command cards for your path that you plotted. The next thing, which is probably one of the most important stages, is the students would work together in groups to test the algorithm that they have written. Before they can test it, we need to know where they're going to start reading the instructions from. Is it from the top to the bottom, or from the left to the right, or the right to the left? So we know this, they place this play run icon here that you can see at the top at the beginning of their instructions. Now this directly links to what's in the ByteEd app. So we're helping them to transition skills from being unplugged to a digital format in the future. One student will read out the algorithm and another student will hold Explorer Ed. So we've got Explorer Ed in his Safari Jeep starting on start, and they will move depending on the instructions that are given. You may find that students will have problems and realize they've made a mistake. And that's great, because what they can do then is they can solve those errors. They can debug the problem. So they'll have found a bug, an error, and they need to debug it. And they keep this testing and trialing. It's called an iterative process. They keep this testing and trialing going until they are successful. So test your algorithm. If you have time and have chance, you can test and trial some other examples. We have Chompy's challenges in the book, and these are unplugged challenges that your students can work through, starting from really simple, going to more difficult at the end, so they can practice their learning that's taking place. We also have lots of other activities which are online on the teaching portal, which we'll show you later. Once again, looking at bugging, you can focus on debugging as part of your practice and your activities in the classroom. For example, you could do something like I've set up here. I've pre-made a path for Explorer Ed to follow, visiting Dinosaur. And I've also written an algorithm. Now, unfortunately, there is a bug in the algorithm. Can you spot where it is? Now I'm going to move along. So if you haven't quite got it yet, you might want to pause and figure it out before I move along. So in this particular one, there was an extra up command arrow. And so there's a bug. And so students will need to decide what to do with that. Do they remove it? Do they change it? Do they add something? Is something missing? And this is a great activity that you can do with your students to prepare them to debug algorithms. Essentially, in a nutshell, that is what the Explorer Ed kit does, the Dinosaur Steps kit. It introduces how to write algorithms sequentially. You can make things more difficult if you want to by adding obstacles on the board. So miss the erupting volcano or the bubbling mud pool. You can add more dinosaurs or you can take dinosaurs away. But the students will use this in a hands-on play-based activity so that they can actually develop these skills and these computational thinking concepts as they are doing. The next part of the ByteEd kit is looking at augmented reality. So alongside the kit, we have our ByteEd app, which you can download for free on your phone. Augmented reality is where you combine a digital world with real life that's around us. It's different to something like virtual reality, because virtual reality is when you're totally immersed in the digital world and you usually wear a headset. Augmented reality is when you've got that combination of a digital thing on top of actual real life. AR is used all around the world nowadays in lots and lots of different activities. And here are just some. It can help us to choose things when we're shopping. You can go to art galleries now and either read about art or see actual art installations which use augmented reality. Gaming, such as Pokemon Go, are using augmented reality too. But it's also used in education. It can be used in tourism. I've seen it used in different cities across the world. And it can also be used in design and architecture when people want to show clients what something is going to look like in real life in situ. Augmented reality is used in the ByteEd app. So you can, like I said, you can download the app for free on any smartphone or tablet. So it can be Android or Mac. You can use the ByteEd app and you can see the icon there in the right-hand side. When you tap on the app, it takes you into the app itself and you will select Dinosaur Steps. So here's showing you what it would look like on the app itself. And when you get in, you can either log in if you have a kit already. We've sent you the login details, or you can, instead of saying use as guest, it now says demo mode. So you can click on demo mode. If you use demo mode, it will not be saved. Okay, so just be aware of that. You have to be logged in for the work to save. So you can explore the dinosaurs by using AR. The best place to start this with your students is by tapping on the glossary. They can interact with the dinosaurs, as you can see our brontosaur in here, by tapping and moving on the dinosaurs, and there is audio there. So they can learn about the dinosaurs themselves that are actually in the kit. And you'll notice that they match the physical cards that are in the kit as well. The next thing they can do is if you tap on the AR button, the camera comes to life in the app. And if they scan the card that they've chosen, you'll see that the dinosaur comes to life and they will have a 3D model, which when they tap on the model, they can interact with. It has animation and sounds. You can also get them to use this as an activity. So set them challenges like, oh no, Tommy the T-Rex is coming. Where would the Triceratops hide? And they could take this outside as long as you have connection to your device. And they can actually explore the habitats where these dinosaurs could live. So you can now explore the AR. The next step in algorithmic thinking is converting algorithms into programs. So a program is a form of algorithm. What is the difference? Well, an algorithm is a set of detailed step-by-step plans or instructions to perform a task or solve a problem. Algorithms are written by humans for humans. Okay. In the Dinosaur Steps kit, you wrote and tested algorithms using the arrow and the run cards. So a program is actually created by using programming language. You may have seen block-based coding, or you may have seen text-based programming as well. It's made up of algorithms. So a program is the code or the instructions written by a computer programmer. Remember, this is a human, and they are followed by a computer or a robot. And they follow those instructions exactly, so you need to be precise. When programming, it converts an algorithm into a computer program. As you can see in the video, we've now got somebody using the app and they are tapping on the command arrows and it creates a computer program, which of course is also an algorithm. They press play and they test it. So you can now go into the app and you can go into the pre-made challenges. So if you tap on the challenges, you can work through sequentially and test and trial some of the different challenges we have for programming. The last step there as well is you can explore AR mode. Now, AR mode means that you can use the unplugged kit. So you can use the Dinosaur Land and you can position any of these cards, so the start and finish, anywhere you want to on the board. You can also put dinosaurs on there. When you scan the board itself, that challenge that you've set up in the unplugged aspect comes to life. And so the students can actually make a challenge unplugged and then put it in the actual app itself and do programming. Online, we have lots and lots of different teaching resources, and you will need to explore these. But we have an interactive website through the teacher portal. You will have been sent a login to access this. Please explore this website. There are lots and lots and lots of activities to help and support you in the classroom. For example, more unplugged activities for how to teach, how to integrate this into the classroom itself. You will see that you will have received an email with login details, and this will take you to our website. So you can go to login, and then you can obviously log in and go to your enrolled course where you will find information on all the different activities. I'm just scrolling through. So here are your different activities that you can have a look at. Included in here is a 10-lesson unit of work, which is very comprehensive and has all the teaching slides and the student handouts created for you with differentiated tasks. There's also other resources on there for absolute beginners, the ebooks. There's even things like 3D printing and extension tasks like challenging cards as well. Oh, and dinosaur fact cards. We also have the chance to meet dinosaurs in virtual reality. You can go to our website and you can have a look at this if you want. Play Code Learn is all about integrated learning too. So when you explore online, there is a web page which actually takes you into linking Play Code Learn to other curriculum subjects. Not just STEM subjects, but many others too. And ka kite. Kia ora, and thank you for watching.